Hello everyone. Got a little repair here, and I was just about not to do this video since this morning I went online and looked, and we saw Pter who at TXBench just did a similar video on this same model radio, and I think his was a VHF problem. This one has a UHF problem, what the owner told me. Now this is the Alinco DR-570, and he said that it had real low receive on UHF, but we're going to go ahead and just check out the whole radio. And I've got the service monitor connected, and we'll hit the sub band, bring the UHF frequency over on the command side, and we'll go ahead and turn the generator on. And there's absolutely nothing showing up on the display as far as any relation to signal. Not anything. So I'll go ahead and turn the attenuator up. And at about 10 microvolts it starts to receive a little bit. It's about a S6. And full scale at about 2,000 microvolts. So yeah, it's definitely weak. So we'll switch over to VHF. And I'll turn the generator all the way down. And it's already trying to break the squelch. And you see right there it's trying to receive, and as you can see, oh, where is it? There it is. We're below 0.1 microvolt on the attenuator. So it's already trying to receive there. And that's at 0.2 microvolts. So at 0.2 microvolts it's receiving pretty good. Let's go ahead and look at the transmitter. And we're putting out, it's about 5 watts on low. And she's about 220 off on the frequency error. We'll switch over to 445.0 and bring the sub over, and we got about 6 watts, and we're about 2.5 kcs off frequency on UHF. So she's pretty far off transmit frequency on the UHF side. So at this point I'm going to go ahead and crack the radio open. I'm going to take the bottom and top covers off so we can set the frequency at center on both bands, and we'll look at the UHF receiver. Okay, I have the cut this volumes down. Have the covers off and you can see the UHF main board. And if we have a look at our schematic, reposition the camera. We can see PJ1, which is where our UHF signal comes in, and it comes right up here through this first dual gate transistor. And every one of these I have ever worked on in this particular brand of radio and the Kenwood radios that are built similar to this, it is always Q1 that has gone bad. Now if you watch Peter's video, you can see how he tested it for ground, you know, to see if there was any shorts, and yes, he was showing a short on this. And I can go ahead and already tell you from experience that this transistor is gone. It's just, it always happens. It's always that transistor in these radios, VHF and UHF. And the one main reason for this is there is very little protection on the front end of these radios. As you can see here, you know, our single comes in, goes through a capacitor and through this little coil, and then there's a capacitor to ground and a variable capacitor, and straight into the FET. These radios are so subject to front end overload, and it always takes these transistors out. So it's sort of a poor design. They're good working radios, but again, you know, this design causes failure of this first RF amplifier. So a way to prevent this is to take the signal that's coming from the antenna port and cut it. Now you can build this circuit on a little board. I'm not going to build it at this time because I'm completely out of these 75 volt gas discharge tubes. And what you got a 10 puff cap going to ground, and it goes through here, and then we got a 8.2 puff cap going to ground, and then our discharge tube going to ground. After that, we have a 12 volt 150 milliamp lamp. Then the circuit goes right on through. Here we have two 1N44 54 diodes back to back, and then it comes on out to the receiver with another 10 puff cap. So what this is was, if this voltage gets too high in the RF, this gas discharge tube will collect it. This light bulb also acts like a fuse, and it'll actually take static electricity and help bleed it off through it. And you know, this light bulb can sacrifice. Now they make this in what looks like a glass fuse holder, so you could put one of these in the radio and just pop it out of the holder and put it right back in. You know, the problem's going to be is finding somewhere in here to put it, maybe here on this back rail here, where we can get it to go at. So you know, it's a very simple circuit. It's a very old circuit. It has been in existence for a long time, and people has built these to go inside of amplifiers also, with two relays to switch it in and out of circuit. But this is the simplified version that will work real good on protecting this front end. Now later on, I'm going to go ahead and reorder some more of these gas discharge tubes, and we'll build up this little circuit, probably on a little small circuit board, and then install it in the radio. Now this circuit that we were looking at was designed by a guy named Phil. His call was AD 85X, and you can Google him on the internet under the 85X receiver front end protection. But basically, you know, this lamp was used in many radios like the FT101, the FT747. Lots of radios had these lamps installed, and you know, to help to protect the receiver, you know. And even a lot of radios had the back-to-back diodes, and these diodes will limit the received voltage to about 1.4 volts peak to peak, or 7 dBm at 50 ohms. The GDT, gas discharge tube, is there to handle any higher voltages that come in through the antenna line and dissipate them to ground. So to get the Q1, we have to remove 4 or 5 screws here, 6 screws, and disconnect all the cabling, then we can get this board out. Okay, so here's the main UHF board, and this is our PJ1, and directly behind that you can see it comes in, it goes through this small capacitor, through this coil, and then here is Q1. Setting right here. So we're going to go ahead and get this removed and go ahead and replace it. Like I say, that I'm not going to sit here and do a bunch of troubleshooting to show you. Peter has already done a great job of doing that in his video on the DR-570, and through experience I already know what the problem is. So just to verify, we'll take a meter and we'll check this thing and just see what the to see if we see that short. I have it on the ohm scale. I guess y'all can see that meter there, and we'll go to ground. .5 ohms. So you can see that transistor is completely shorted out. So let's go ahead and get this thing off. Okay, I got some capstan tape around it to keep from blowing the other components off, because that does happen from time to time, and we don't want to blow everything off the board. I'll let my hot air warm up just a minute. I wanted to do this under the microscope. I moved the microscope on the other side of the bench, and I got a patch cable to plug the microscope in and then around to the computer. Well, the patch cable I got was a cheap one, and it's no good. It worked for about 2 days and already quit. That simple to get off. No problem at all. Well, I'll get this cleaned up and go ahead and get the new transistor in place. Well, I'll go ahead and get this cleaned up now and get that old solder off. whenever you're doing this, you want to make sure there ain't no solder balls left up there on it. Alright, now we're left with a nice clean pad to get this done. Alright, I got the new transistor installed. We'll go ahead and get the radio board back together, and we'll test out our UHF and see if that made a difference. Okay, the rig is all back together, and I still have the IFR sitting on about 2K microvolts. So we're just going to take it and turn it down, and we'll go to generate. Oh yeah, that's 5. That's 0.2, that's 0.1. That's about 0.15. I could put the cyanide meter on here and check it out, but I'll do that later on, and make sure that the receiver is up. So you can see, very same problem that Pter had in the DR-570 he was working on. And again, the reason of this failure is poor design front end, and it's just, you know, a nature of the way these radios are made. So what I want to do is I'm going to try to order some parts. I like to get everything in SMD package, you know, which that'll be all but the bulb and the gas discharge tube. You know, I think you'll find those in the SMD package. I like to, you know, populate it, put it all on the board. Then all we got to do is make this into a kit form, so that you simply unplug this TMP connector. For those of you that always wonder what that's called, it's a TMP connector. And probably can reroute this wire here behind it and out the other side, and build this little board to mount here on this heat sink, and then use a some kind of way to ground it, either to this top screw here with a little copper strap, and then you would plug this into the board, and then there'll be a cable coming off the board that would plug into here, into PJ1, and that would solve a lot of problems with the front end of this radio, you know, blowing out that transistor. That transistor is a 3SK1845, if you want to know, and you'll find this also in the Kenwood 2 meter 220 version. The 220 version also runs the 3SK1845, so it goes from 220 all the way up to 400 megs on the that one transistor. So it's, you know, pretty broad-banded little transistor. And just to show you, this was a strip of about 10, and I've got one left, so I have got to get on eBay and order some more of them, because probably do one every other month or so. As we noticed before, on the UHF side, we were about 2.5 kcs off frequency on transmit. And take a look at the IFR. I got it set for 445.0 megahertz. And if we look at the frequency error, we're on the 3 kilohertz scale. It's about 2.5 kcs off frequency. So we need to get this thing back aligned up and see what's going on here. Okay, so to adjust the frequency, if you remember, UHF was about 2.5 kilocycles off, and VHF was close to a little more than a half of about 200 off. So to adjust this, what we're going to do is go to 145 on the IFR, and we're going to come right in here and we're going to adjust TC1 on VHF, and then we'll show you what happens to UHF. We're on 145. See if I can get a tool in here. Kilohertz. Just a little bit high. It's very touchy. And there we go. We're so close to 0 now. We'll go ahead and switch back over to 445 megahertz, and we'll do the same thing on the IFR. 445.0 enter. And you see we're so close to 0, and we probably can touch that up just a little bit. There we go. Just about on 0, that's close enough. Okay guys, so there you go, another Alinco DR-570 back up and running until it takes its next front-end overload, which is going to most likely take that transistor out again. And again, I wasn't even going to do the video. Peter did such a great job on his. I'll leave a link down below to his video if you haven't seen it. He did a wonderful job at troubleshooting, so I didn't see no need to go in and reinvent the wheel on troubleshooting this radio and trying to take anything from his video. It's just that I was going to do the video on this today and get real into it, but after watching Peter's great video, there was no need of me doing that. We will again, front-end overload, static electricity. We'll take this transistor package out easily. It's a known problem in this type of radio. And again, to prevent that, all you need is this little circuit right here. And I'll make a I file this and place it on my website for those that want to download it. And I'll leave this overhead shot up there for just a minute. If you just want to take it and snip it off your computer and make you a JPEG out of it. But real simple. 210 puff caps, a 8.2 puff cap, 75 volt gas discharge tube, 12 volt 150 milliamp lamp, and a pair of 1N 4454 diodes back to back. And you just put this into the receiver line, not through the transmitter. You cannot transmit through the circuit, but through the receiver line. This will go towards your antenna, this will go towards your radio front end, and this will save the front end of your radio. Hope you enjoyed it. Leave your comments down below. You know, click the show more tab for links to this on the website and to Peter's video. So we'll catch you in the next video. Bye now.